All right, so let's begin the lecture today. As I said, we will switch into a new topic, and uh, you might have heard from your upperclassmen or your friends that hey, this is the part that basically is the main content of this class. It's a new language, so please keep that in mind. And also, I understand that because it's a new language, it's a lot of new material for everyone here, right? Well, if you have write C code before, it might not be new. You might get bored in the first few slides, a few lectures from now here onward until we get to basically the next module when we talk about assembly, which at that point I feel like is probably new for most people. So please bear with me if you get bored and you want to ask more advanced questions about C or even C++. Feel free to ask me after the class through the email. I will not mind answering any questions. I'll try to get back to you as soon as possible. Okay, so let's begin. A quick announcement. First of all, assignment 1 is posted. I posted late, like Friday night, Saturday, early morning, like 2 a.m. Uh, there'll be no class Wednesday this week, as I kind of announced since the first week that this Wednesday I am so sorry. Like there's a interview day for TGGS, so I need to actually spend time interviewing students. So I cannot make it to the class. We will make up on Friday from 10 a.m. to noon. I will post the slides, and because it's actually a follow-up to how to use C language, I would assume that most of the time you just go through the slides, go through the video, and at the end of the day, you need to kind of try the example code on your own. And then feel free to ask me questions because that's how, in my opinion, that's the best way to understand a new language. Which is if you got stuck at certain things, you can always consult people who use the language before. I am one of those people. Your upperclassmen, if you have contact with them, that's also like another good resource. It's like, okay, how do I do this? Even your friends, right? So it's like, okay, I'm trying to get through the assignments. How, really, what is the exact, like, say, the way the syntax work? Uh, why do I get this certain error? What do they mean? Feel free to check with me. Feel free to kind of collaborate, but not copying, right? This is another thing I want to stress, right? There's a fine line between collaboration and copying. Copying is something like you look at your friend's monitor and it's like, okay, that's what they type, so I'm gonna type in the same thing, which without knowing what they're doing. Uh, at the end of the day, it's so hard for me to track who is cheating, right? I'll try my best just to enforce certain amount of fairness. But the end goal is like you should learn. If you don't know how to write program in C, you are going to struggle going forward. So if you feel like, okay, I want to catch up on certain syntax, how does it work? Why do I get certain errors? Check with me. I mean, I don't mind answering that. I seriously like in a lot of cases it's as simple as you forgot semicolon or like the curly bracket at the end of things like that. As I said, past lecture and videos will be available. I think everything is available now. I actually have another set of like playlists that I gave a talk at Chulalongkorn, which is like how GPU works in case you're curious. So you feel free to check those out as well. I'll keep posting these lecture videos uh, on the same playlist so that you can kind of like go through all these lectures if you want to kind of look into certain materials. I think one thing I might try to do at the video description to be like, okay, these are the things we cover on this lecture. But depending on how much time I have, if I don't have time, I will just leave the video title as is. That's the video for this lecture. It's about these topics. That's it. And then you kind of power through the video. All right. So let's go through the content of this class. We kind of like talk about this a little bit. What is a computer, right? Let's go a little bit more in detail now that I think you all understand, okay, what constitutes like a good definition of computer. So logically, this is what we think, right? You might have heard things like logic gates. You might have heard things like uh, adder, multiplier, the hardware that goes into the memory. You might have heard about the CPU, right? The central processing units. Those are logic gates. How many of you have taken like a logic class, like and or how does it work? Like A and B means that A has to be true, B has to be true to make the whole statement becomes true. Like those kind of things. How many of you have like heard about these topic? Or how any one of you never heard about this? So let's say I do A and B. What is the condition that both this whole statement becomes true? A has to be true, B has to be true, right? That means that A and B is true. Otherwise, this is false. That is a theory that if you can build an or, and a not, you can build any single computation in the world. Basically, with that, it means that if I can build a circuit that can do an or and not, then I'm good and I can build a computer. Control signals, basically that deals with communication. How do I tell the CPU, run this code, run that code, run the other code, on those kind of things. Storage is, as you know it, hard drive and SSD. When you buy them, you store your files in there, right? Uh, physically, these are just tons of bits, tons of electrons, right? I believe you should heard of the word electrons and know what they mean. These are just electrons that move around in wires, right? It has certain conductivity. You can move from one location to another. That's it. Bits. How many of you never heard of bits? Zero and ones. Silence means that I assume everyone knows that at the end of the day, you can represent number using zero and ones, right? Is that the case? Is that not the case? I just want to make sure we are all still on the same page. Okay. Yes. If I'm going too fast or if you feel confused, let me know. Yes, binary values. Right. So any numbers can be represented using zero and ones. Right. And what else? What else do we know? We know electron exists, right? Which means that if something has electrons, we can say that's a one. If something doesn't have electrons, that's a zero. I can move electron around, right? I can just kick it out there. I want this particular storage element to store a value zero. What do I need to do? Get rid of all the electrons. Make it low voltage, right? Electron has a voltage value tied to that. The more electron it is, the higher voltage it's basically it has, right? So a low voltage, which means that there's no electrons here, will be a zero. A high voltage will be a one. This is actually how computer handle any single value. You have a capacitor. Do you know what is a capacitor? Think of it this way. It's a bin that store electrons, right? If the electrons, this is a value one. If there's no electrons, this is a value zero. That's it. This is what your computer consists of. Okay, we're done for this class. No, I'm joking. In any case, this is how you can store a ones or a zero. Transistor is kind of like the same, but it's a little bit faster. But think of it this way. You can store a one or a zero. These two will tell you what to do to move electrons around, right? These follow the law of physics. Basically, we are converting mathematical function, which is zero and ones, right? Zero and ones into a real thing, physics, computer, transistor, resistor, anything you can buy from a hardware store and put together into a actual working computer. We are actually making math materialize into existing thing, right? Any questions about this? Basically, you represent ones and zero using either there's no electrons here or there are electrons. And with ones and zero, if you know that if I can implement a simple logic and or and not, I can build anything. I can build an adder. I can build a logic that do multiplying. I can build a logic that check for if else. I can build a logic that compare two value. I can build a complex logic to do fancy things like recursion, uh, Fibonacci, compute factorial, search, doing machine learning, right? So if you can convert this to binary value, you're golden. One more thing, how many of you have heard about how many transistors can be put on a chip on a CPU? And why do we want more transistor? Have you heard about this argument saying, hey, we want the transistor to be smaller and smaller and smaller? With like they say right now it's like 7 nanometer technology versus 10 years ago, which is 65 nanometer. Exactly, yes. When you can add more transistor, you can add more bits, right? When you basically it means that I can cram more things into the same area. If you buy a CPU, if you go to say like I don't know, like if you go online to a store and buy an Intel CPU, it comes with a fixed area. This is like about I would say like 4 centimeter by 4 centimeter, right? Area. Transistor is a physical thing that you have to fit in that 4 by 4 centimeter area, which means that if each of the transistors are smaller, I can fit more things in. Right? It means that I can do adding more effectively. I can multiply things a lot faster. I can do matrix multiply, which is used a lot in machine learning, a lot faster, right? Which means that the more powerful CPU requires smaller transistor. Basically means that we can have faster CPU. And okay, sorry about having my writing on top of this box, but basically what I'm trying to say here, we have a bunch of bits. And somehow it means something. Computer runs, it can run your program, right? So let's actually talk through what happened when you write a program and when you hit that enter button and run the program. What happened when you double click on the Chrome button and so that you can browse the internet, launch YouTube, and somehow magic things happen on your monitor. Right? So these are the computer nowadays. There's embedded devices like the Raspberry Pi that you can buy. This a cheap device, a simple machine, but it runs. It's a full-blown computer. You can install Linux on it. You can use it to emulate like a PlayStation 2, for example, or like a old Super Famicom and play it on the TV. It can actually drive the output to the TV. You have this fancy GPU, right? These are one of the not fancy now. It's 1080. This came out about 2 or 3 years ago. Actually about 4 years ago. This particular model is actually popular for one reason. Do you know why? The 1080 GeForce GTX. How many of you heard about Bitcoin? Yes, exactly. People buy this thing to mine Bitcoin. And it ended up driving the price of these particular GPU about like 4 or 5 times of the normal prices. At that point, everyone, including me, who want to buy a GPU to play games, is like, okay, I'm not gonna buy a GPU at the moment because Bitcoin is like destroying the GPU market. But yeah, people buy this to mine Bitcoin. There are a reason why this is really good at doing that certain task. If you're curious, send me an email. It's out of the scope of this class. We will cover this thing when we talk about computer architecture, which go into why the GPU, what exactly GPU is good at, and why it works. What is this? This is a cluster of machine. This is a supercomputer. So I'm sure you've heard about this terminology before. Supercomputer is basically it's a bunch of computer connected inside a much bigger compute platform. You can run a lot of heavy workload in there. It consists of machine that have terabytes of memory. It has petabytes of hard drive and the SSD. You can run complex things, right? That compute things like how to predict the weather. This particular picture is from Lawrence Livermore National Lab in the US. There are quite a few of them around the world. Actually, we do have one in Thailand. This is called the Tara computer. Right? This is at Thai SC. If you are interested, I know people who are like basically hiring interns to kind of like help them managing like jobs that people submit, scientific application that they want to run. Sometimes people don't know what they are doing with that program, and your job is to kind of like tell them, hey, don't request 40 GPU or like 30 CPU to run your program because you're not going to need all of them. So this is actually when I mentioned internship opportunities. One of them is at Thai SC. They have a supercomputer, and they actually want to develop a way to like allow people to easily access the resource. And this is actually one thing that I am surprised when I got back to Thailand because I never heard of this project before. It's awesome. It would allow a lot of high performance computing that people in Thailand would never be able to dream of running on those machines. You might have seen this from a long time ago. This is an old image, iPhone, right? These days there's multiple cameras in the back. iPhone is a really, really powerful computer. They are not joking when they say their CPU is faster than 95% of the laptop in the market these days. iPhone CPU is one of the most powerful CPU for users level. Basically, it's actually really fast. And that's actually why when you buy an iPhone, you don't have to buy a new one because you feel that the phone is slow compared to when you buy like Android. And this is like an internal basically internally, if you go to Google and work as an intern at the one of the Android phone developers, they would use iPhone as their like benchmark, and they want to reach the level of the iPhone in terms of the hardware. That's how good it is, right? It's a really really powerful machine. And I'm not the Apple fan, right? I know how they price thing and it's like super expensive, but this is really a really really good hardware design. Uh, you can even have like this thing like a smart gadget, GoPro, right? You can. How many of you own a GoPro? Out of curiosity, how many of you have played around with it before? Yes, no. Uh, okay, yeah, like once some of you have played around with it. Okay, awesome. One thing that you might have realized is you can actually sync like whatever you want to take a picture, you can actually use an app on a phone, right, to see what the camera is seeing. That is a program basically allow the phone to stream the picture live on your phone. And then you can take a picture, just hit the button on your phone, and somehow it would record the video at the GoPro would see. It actually requires a lot of small piece of program to have this computer on this GoPro devices, and you can send it all to your phone. Do this synchronization, somehow have the live image playing. Basically, it's a video, right? And then you can record, you can choose to do certain things from your phone. You can also do the same thing from the little like device as well, the GoPro device, right? And to do this, one really nice thing that you would actually, I think by this point, like if you write Python code before, you then realize that there's a lot of things that you do not have to do. This is called the power of abstraction, right? This is now we go into a more like a theoretical level, right? When you write a program in Python, do you have to know how the hardware works? Do you have to know how the memory is organized? Do you have to know how the virtual memory is organized? Do you have to know how does the hard drive read the data? In many cases, you don't, right? You just write a function, you call certain APIs, and magically you got the results. And this is awesome. Why is this good? It allows you to write a program quickly so that you can test, run, and actually get the output, right? This is great. These are things that you don't want to understand when you write Python code. You don't have to understand how the instructions in the assembly are executed. Right? You don't have to care too much about, okay, what if I run this same piece of code on a different machine? Would it run on an iPhone versus your desktop, right? One thing that you might not have realized is that your desktop is using a different hardware language than an iPhone. iPhone uses an ARM architecture. Is a language, is a hardware language provided by ARM, which is one of the hardware company. Your desktop uses Intel. So Intel and AMD processor use a different language. Somehow when you run Python, you can run on both of them magically. Yay, perfect, right? It's make your life a little bit easier. You don't have to care too much. You will like the experience programming in Python versus Java versus writing in C versus writing in C++, and C. You will start to hate your life when you have to write in assembly. And you probably, me too. I would probably go insane if I have to write in machine code. Have you seen a movie and they have to use punch card to write a machine? How many of you seen the Imitation Game? The the movie about one of the machine that cracked the code in World War II. Yeah, those spinning, rotating, is actually that's how they program. That's how they program the machine, right? And at that point, you need to program every single piece by yourself. That was back in the day where human labor is cheaper than machine. You actually spend a lot of resources building that machine. To hire more people to program the machine is a lot cheaper. Right? And you actually one of those like Enigma machine, right? Uh basically at that point, right? At that point. Well, actually Enigma machine is kind of like the Enigma is the encryption, right? So it's the machine that kind of break the Enigma machine. Uh just to make sure we are on the correct terminology. But anyway, to build those kind of machine and to program it, government is willing to hire a bunch of scientists to code it, right? These days, build it. Is that the same? No. You you just spend like a few $100 buying a CPU. It's actually a lot more powerful than those machines. Then labor is expensive. If you work in Silicon Valley, actually let me ask you this question. Let's say if you work in Silicon Valley, and you graduate from like undergraduate or a master degree, I would now I'll have you guess what is the yearly salary of those engineer in dollars before tax. Anyone want to take a guess? Okay, that's a really cheap. Okay, that it's about $100,000 per year. That's the average in Silicon Valley. If you get a PhD, you're looking at between like $180,000 to like $300,000. Uh, so yeah, so these labor is costly, right? To a company, one engineer costs so much. So they want to abstract your effort. Writing code in Python is a lot easier, so it takes a lot less time for a company to deliver certain things. Then, if you need to optimize the performance of your code, then you go deeper and deeper. Now, at some point, you might need to write things in assembly. There's actually tons of job openings if you are willing to work in C code, C++, and assembly, or GPU CUDA program. Those advanced, relatively more advanced language is still a hot thing in the market, and they want to hire you because there's not a lot of people who's willing to go that way. So if you want a job, that is definitely one good direction. My hint, right, for sure. Uh, Cobalt is a really old language. That's another great example of what happened if you forget to store a source code and you only have the binary code, the executable to run. There's actually quite a lot of program back in the day where like NASA is trying to send people to the moon that are written in Cobalt. There's a lot of big utility in like say the US that have code in Cobalt, and somehow they have to have people who know how to program in Cobalt to maintain those code. There are works that go into how to translate Cobalt into other languages. Yeah, it's okay. Your mom, not trying to be rude here, but if you look at like generational, like how much gap, right, between where we are right now to back like 30 years ago. 30 years ago, Cobalt is easy to understand than punch card, right? So it's a lot easier to program comparing to like individual wires. Think of it this way. Uh 50 years ago, 30 to 50 years ago, we are around the same phase as what we have in quantum computing right now. Right now, quantum computing is we are controlling this thing called qubit. And we are trying to figure out what's the best way to abstract it so that people can use it. And it's not easy because there's a lot of like physics that go into how to control these devices. Things like quantum entanglement. It turns out that if you look at two binary code, it's a qubit, right? It's not a binary code, but let's say you want to change the value of this variable from 5 to 10. It turns out that the value next door would change too. There's some entanglement and you don't know how to control it. That's hard. So quantum computing is kind of like back. If we look back, it's exactly around like 1970s where we are in terms of programming languages. It's still a lot of research going into this direction and a lot of work that has to be done to make it easy to program like how we program Python on a computer, right? And I know I'm getting a super sidetracked here. I hope you're still with me. I hope this is like an interesting tidbit in history and you're not sleeping yet. Uh, so your question, right? Your question by this point, I've been telling you, okay, programming things in a high level language like Python is good, right? Yes, obviously they are good, but wait a second. So what if I ask you this question, right? You run code in Python and it's slow. This happened too. What if you run it on an IoT devices and you ran out of battery? This can happen, right? There are a lot of embedded devices and IoT devices that have limited battery. So your code can actually drain the batteries to the point that you cannot run. One example is when I was at NVIDIA as an intern, one thing that I've heard that I find super interesting is when they design a hardware and a program that go into your phone, they have energy budget that they cannot exceed, because if it go be above that level, you cannot have big enough battery for your phone. Basically, you can't do fancy tricks that you would be able to do on your desktop. You have to rely on energy efficient design. Right? So energy is another important when you want to go mobile or go like IoT. When you need to switch to a new computer and it's magically running slower, even though the computer is actually newer, it happens. It can happen, right? Some program produce randomly incorrect results. Sometimes it's correct, sometimes it's not. You run into system level bugs that crash your computer in Python. Right? What do you do? Okay, let me ask you, what do you do in Python if this happen? Yes, run to Google and kind of like trying to figure out if certain line of code caused that, right? Basically, you consult Google and hopefully someone ran into that exact same problem before, and they would tell you, okay, this line, this particular function that you call in Python caused the program to crash. If you know C, or if you program in C, you have a lot more control into whether you would crash the thing or not, or you would avoid crashing this. Uh, for a few of you, so just to make sure that people who took OPL last semester, because I kind of right now I'm shitting on Python to motivate why C is good, right? When I'm teaching OPL, I'm cheating on C to motivate why Rust is good. It's actually every language has a trade-off. So for a few of you who took OPL, C has certain benefits, but then if you can program in this language called Rust, if you take OPL in the future, you will know it actually make your C code a lot less bug prone. Uh, Sometimes your code can actually shut down computer. Knowing how computer really work would help, right? Would help. So let me kind of go over the thing called computing stack. Right? And this is the stack. You, at this point, when you learn Python, you are around here. You have a problem. It can be a math problem. It can be just a problem you need to solve in real life, right? You convert them to algorithm. Algorithm is step-by-step logical process of how you solve the problem using a program. And you write a program. Right? And we will spend most of our time in this class in here. Right? And when you run a program, be aware that a lot of things happen to convert everything you write in text, right? The program into electrons. We will not touch anything in here. This is too low level. We are not physicists. We are not physicists. We are not electrical engineer. You are not circuit designer. You are not computer architect. I am. If you're curious, let me know. I have a lot of things to talk about, but we are not going to discuss this in detail in this class. When we talk about assembly, this is where we'll touch a little bit. Where when we talk about C, this is where we are. The C code right before you compile. You will learn about the compiler a little bit in OPL. You will learn about the runtime system in the OS class. You will learn about the fancy tricks that we hardware designers do in the computer architecture. These slides essentially give you a high-level overview of what if you want to dig deeper into how computer is built, designed, and run your program. Why is this a good thing? If you can make computer faster, it will make every single program run faster. Downside, we get paid less money than people who look into machine learning. It's the hard fact. Like if I go to work at Google, I would actually get paid a little bit worse base salary compared to people who do machine learning because they make a lot of profit and we don't. But we make sure that computer runs. Uh, so yeah, system, which is what we are right now, like OS system, and architecture, which is another set of class, a compiler, kind of connects gates and wires to computer codes. And everything at the end of the day, as I said, everything becomes data, ones and zero, right? So when you run a program, what happens is the OS, the operating system that we covered the first day of class, program is a file in Linux, right? This program is a file in Linux. Where is your file stored on your computer? As in, like, what is the device that store your program? When you install a new game, where does it go to? Hard drive. Yes, exactly, right? So you somehow have an OS. Look at that location in the hard drive. Copy this to the main memory where you go and buy DRAM. Whenever you joke to your friends who have 20,000 different tabs on Chrome running and say, hey, you run out of memory. Those those is that is the memory where your program get copied to. Then the processor, which is the CPU will then access the program and the data, the input and output and everything to the main memory. That's the furthest the processor is going to access, basically. OS copy the program to the main memory, copy the data to the main memory. The program itself is running on the CPU that you buy. It interacts with the memory. Memory becomes this central interface between your data that you store and you download to the CPU. So let's give an example of what happened when I run a program. This is a really simple program, right? I initialize I to 10, j to 20, and I do I plus j, 10 plus 20. Right? It's as simple as that. This is a program, obviously. It's a short, simple program. What happened is this program is still in human-like language, right? What is the language that machine understand? 1 and 0, right? Basically, it only understands ones and zero. So somehow you need to convert this to a bunch of ones and zero, which we will not discuss in detail. What are those exact patterns? Just know that there'll be some magical black box that takes in the code and spit out this ones and zero that computer knows what to do with it. Once you have this one and zero, the process of converting your program to ones and zero is done through the compiler. Program is fed to the compiler spit out ones and zero. This is basically your binary code. Right? This is like all those .exe that you see from Windows. If you run a game, you would double click on anything that .exe, right? And hopefully that's not a virus, but basically then the program runs. The phase of making sure this program runs on a computer is handled by the runtime system, the operating system. So this is the OS, right? The OS basically copy this ones and zero to the memory. And because this ones and zero is understood by the machine, this is basically, think of it as a machine language. It understands exactly what the heck is all this ones and zero. It knows exactly what to do. Then anything below this level is all hardware. So we'll skip about all this. Once the computer know what to do, we'll trust them and they'll do exactly what we tell them to do, right? Any questions from the program down to the ones and zero? Basically, now I'll give the overview of what I just talked about, right, in the past 30 minutes.
อาจารย์
Yeah,
ครับ
yeah.
so all the programming language is just they try to make binary into human language as much as possible ป่ะครับ
You mean the programming language, right?
ครับ like Python เลย
Yeah, basically something like that. Because at the end of the day, this is how human work, right? I cannot just type in 10111011100011. I have no idea what I'm doing. The programming language allows you to type in like things like ni equal 20. They would automatically convert that into ones and zero that correspond exactly to that line of code. Right? Let think about it this way. You have a program, right? So let's say this box is your program, right? You have in that's just like one simple line in I equal 20. That's the only thing I do in this program. Like super simple. The first process is I would compile this. This program is still a program, right? But this is uh this is programming language. This is a binary representation of this same program. So it will be just a bunch of 1 and 0. Right? A bunch of 1 and 0. This is stored on your hard drive. Let's say it's stored in here. Little program stored somewhere on your hard drive. Let's say you want to run it and see what's the result of my program. Let's say this is the phase that we'll call compilation. You convert your program into something that machine understand. This is what happens when you run your program. So you start from here with the hard drive, right? This thing get copied into the main memory. Or DRAM, right? This thing would get copied somewhere in here. So now your program, the ones and zero, will be in here. And then you have the CPU, right? The CPU. I cannot write properly. I don't know why. Okay, CPU. No, let me finish the U. Okay, CPU. Processor that you buy, right? It would go and access this program. There are a lot of things that go into here that cause the magic to happen. This magic would read this random ones and zero and do exactly what you tell them to do, which is in I equal 20, and that's it. So this is a high level overview of what happened when you run a program. This same thing can, with this exact same process, happen when you run, say, Google Chrome and open a tab and watch YouTube video. Okay? Any questions about how this high level process work before we dive into how to write C program? This this is my experimental material to kind of like make sure we connect between, okay, I have Python code and I buy a computer. What happened in the middle? I hope this help with the understanding of like what happened to my program basically. And if you are curious, once we dig deeper into assembly, we'll keep explaining the thing that happened in this overview figure. Basically, we will then talk about, okay, what does assembly code means basically? What does it mean to do load and store? You don't have to understand any of these. We'll make sure you do after the midterm, right? So basically from here on out, we'll talk about any questions until now? I'll wait maybe like a few minutes. And you might be curious, to be honest. You might be curious about why do I have to kind of teach all this unnecessary. Well, hopefully it's necessary to understand the big picture, but you once you graduate, a lot of you will end up doing certain like develop certain application, like maybe computer vision, machine learning, uh, some embedded system work with IoT devices. I want to make sure there's also a big job opportunity that are dealing with the basically low level languages that is in high demand, especially nowadays. It's like the demand is actually sky high. Like if you know how the system work, if you know how the hardware work, there's always company that want to hire you, and you'll be actually harder to replace because it's harder to train people to understand system. Uh, that's it basically. Okay, so C code, you might be heard hearing from your friends that hey, this is complex and hard and like stupid because it doesn't really do a lot. Python is more powerful. Why should you care? It is extremely fast. One goal of every single company once they have the experimental code out and they want to launch a product is they want to make sure your product is fast. You can do it with C. You have direct control over how you manage the memory. The memory that I just told you where it store your program is where you store the data. It's also where the performance bottleneck occurs in many programs. My research group actually is directly how to design a memory to make sure your program run as fast as possible. This is how important the memory is to performance. It is slow. It is a lot faster than hard drive, but still really slow. You can write, if you can write C code really well, it can be minimal and clean, right? And it's compact. Compact means that you can run this on a lot of IoT devices. A lot of these embedded devices doesn't have a lot of memory to store your program. So you want to make sure that your code is as short as possible. So C is a really good language for that. Now let me explain why not C. And that's actually multiple reasons why not C. Uh, you need to manually manage a bunch of things, including the memory. We'll go over this in a few lectures, and then it will be clear to you what I mean here. It is annoying. It can be buggy if you're not careful. It's not object oriented, but then there's C++. So this is not really like a big like disadvantages because you can always use C++ to implement the object oriented version of your C code. And there are many creative ways for you to make bugs, right? I still make a lot of mistakes, even though I program in C for a long time. And you don't have to be that creative to create bugs. It's like so easy to have bugs in C code. And it's not the programming language that are really good at detecting bugs. So you have to have basically you have to kind of stare at your code and figuring out what caused my bug. Now that we talk about pros and cons, let's go deeper. So how to declare a function in C? Every single program starts with a function. Function defines what you do with the program, right? So similar to Java, each function has a return value. If you use Python before, basically it's when you declare a def, like a def, which is declaring a function, and it returns something at the end. When you call that function, that's the return value. Input function has to have a type. It can be integer, it can be character, it can be a string, it can be a bunch of things. It can be a collection of integer, string, and another group of integer altogether. These function, as I said, a program is located in the main memory, right? So these function, let's say you do add, which is just a plus b. This function is called add. It returns an integer. It takes two inputs, A and B, and it performs the addition. Return the result, which is the addition of A and B, to whatever call this function. Any question? All right, so in terms of how to write C code, there are, so basically these are a few examples of how you can write it. And then the in-class exercise, which we'll have at the end of this lecture, is a practice for you. So the way, because we are not in the same room, usually I would go around and like look at your monitor and trying to tell you what's going on, right? So we will figure out how best to do that while we are at the in-class exercise phase. In the worst case, you can always put a screenshot at your monitor and send me an email. I'll tell you what's wrong with it. Every single code starts with the main function. Let me deal with the windows. I think the storm coming is kind of hitting my window. All right, sorry.
The device is offline.
And I'm not talking to you. I'm like, sorry. My Echo devices think that I'm asking her something. Anyway, so every single program starts with the main function in C. After you compile a program, yeah, we can try that. I don't have Discord installed, but it might be a good idea for office hours. So let me try to figure out how to work through Discord. I play a lot of games, to be honest, but I grew up at the age where Discord doesn't exist. So I never used one before. So let me kind of like figure it out, see how it works. Um, but yeah, I would not mind to try to understand how Discord work in detail. And if that's working well, this might be a good way to have a way to debug your code, how to work through a lot of problems.
อาจารย์ครับ
Yes,
last slide you say that all function is to return a value, right?
yes.
How about void? What is it called that value like
Very good
void?
question, actually. So there's a function that start with a void, right? Void. What does void mean in general? In English? It's nothingness, right? Void it means this is nothing. So if you start instead of an integer here, if you use void, it means that I'm not returning anything. It's a function that you call and you're not expected to return anything. So thank you for the correction. I'm wrong here. Function doesn't always have to return a value. If you declare a void function, it doesn't have to return a value. Right. So the main function is where you start your program. Whenever you run a program, this first line in the main function is where you start when the program starts. This is the exit code of your program at the end of the main function. So you can return other value as well. Basically, you remember the shell scripting? That's the one command that look at the last command exit code. If you put a different number here, for example, if it's a HTTP program and it returned the value 404, it knows that, okay, I'm trying to find some address in the internet that doesn't exist, right? So it gives you hints of what's going on in my program. There are multiple data types. If you use Python before, it's the same concept. You can have integer, you can have a character, you can have a floating point number. The difference between integer and floating point number is that integer only have the numerical number 1, 2, 3, 4, 5, 6. Floating point number allows like something like 0.123, 7/8, right? Or those numbers between 0 and 1, 1 and 2. Character is basically a character, alphabetical character. These data type represent value, the actual numerical value. So let's say you have a character that is an A, the letter A. This letter A, the value is 65. Why is it 65? This is the ASCII value of A. And that happened to correspond to 65. A new line, for example, is either 10 or 13, right? C only support basic data type by default, which means that the first thing, if you have a complex data type that consists of 5 integer together, you need to define your own complex data type. There's no Boolean, there's no true, there's no false, there's only 0 and non-zero. 0 means false, so if you do if 0, 4, 8, else, what B? What is this equivalent to? This is basically means that I'm gonna keep running code B. I never have to run code A because it's always false. It's basically if false, but C doesn't support false, so you have to write in if 0. Anything that evaluates to 0 is a false. I would tell you ahead of time one really easy mistake that you can make to compare a value. Like if you want to check if A is equal, right, to B, you would write in A equal B, right? This is how you check if A has the same value as B or not, right? This is clear, right? Any questions with this? What will happen if I write this? So what if I have only one equal sign? I'll just tell you ahead of time. This can be a headache when you try to debug a program. Because it's so hard to detect this kind of bug, it will not say it's an error. It's actually a totally valid argument. Exactly. It would actually assign the value of B into A. And do you know what's the return value of that? It's the value of B. So depending on the value of B, if B is 0, this is a false statement. If B is a 1, it's going to be a true statement. So make sure you want to compare two things, put two equal sign. I make that mistake before. I think I was an instance where I wasted like a day of my of my time to like finding out what the heck is going on with my course because everything looks correct. Yeah. So 0 equals false. Anything not 0 equals true. Variables, you can use variables in C. It's the same as how you declare this in Java or Python. You can assign value to variables similar to Java. These are the example. I hope there's no question here. If you have question, go through this again. It's kind of super clear. Then you can assign value from one data size to another data size. For example, int the size of int is less than the size of long integer, right? So if you do this, if you have d as in a long integer and you have b declared here as an integer, right? You can do d equals b. That's fine. It would assign the value of b into d. Just make sure that b, the value of b doesn't overflow when you do the assignment. We will talk about what does it mean to overflow in a few more lectures. So we are not going to discuss it now to make you even more confused. We will talk about this assignment in detail. All right. We just want to let you know for now, you can assign the value to variables. There are ways to declare variables in C. You can convert data type by doing things called casting. Let's say right now A is a character. So let's say we do char A equals letter A. Int of A is basically 65. Right? Any questions here? Basically, you convert from the letter A to the integer representation of A. Be careful when you convert one data type to another. Why is that the case? If I say int A is 12, B is 5, A divided by B is not the same as if you have to cast A and B into float, which would do. So basically, over here, A over B will equal to 2. They would cut off all the remainders. Okay. 12 divided by 5 is 2. If you do float A divided by float B, in this case, what do you get? 2.4. All right. These kind of bugs make space shuttle exploded before, and I'm pretty serious. This happened, right? So be aware when you write this kind of code where conversion happens, when overflow happen, it can cause like something really bad. Operators is similar to Python and Java. A plus B means that I'm gonna add the value of A to B. B plus plus means I'm gonna increment B by 1. C divided by D, self-explanatory. A mod 10, which is I'm gonna see what's the remainder of A divided by 10. Is equal. If you use equal means is equal. This is not equal. This is less than. I can write or equal to. All right. I hate my handwriting, but that's as good as I can get. And then after that, know that A equals B and A equal B are different. And yeah, this can become buggy. There's a logical operators as well. Okay? You can do and, not, or by using this. This is useful when you have an if-else statement that you want to check multiple conditions. A equals B and C equals D. For example, you want to check if A and B has the same value and C and D has the same value. You can replace the and with the or. That would also serving different purposes. You can use the bitwise operator to not to do the bitwise and bitwise or, bitwise XOR, and left and right shift. Basically, if I have the binary value 1101 and I do left right shift by 1, you're gonna get 110. Basically, you shift everything to the right by 1, right, by 1 bit. The same thing goes with the left shift. Uh, you can put in comments on your code, and I highly encourage you to do it for your assignment. It allows me to give you partial credit in case you don't have the full solution working. Just give me your thought process. All right. So double slash means that you want to comment that one line. This slash followed by asterisk is how you comment a section of the text that go across multiple lines. That's a control structure. You can do if else. I don't know why they have to copy up if else. And you can use switch case. Here's the example of switch case. If else is something like this. If condition else switch is something like you have switch. This is the variable that you want to check. Yes, so if you have else if, right, so you can do this, else if condition, and then else. You don't even have to have the last else at the end as well. So you can have the if, right, the if here, else if, and then else. Else would be like the remaining cases. If you don't want to handle the remaining cases, you don't have to have the else at the end. If you don't only have one or two, like two choices, then if and else is fine as well. So where do you want to check? So let's say you switch A, right? Case 1, this means that if A is 1, it will do B plus plus. Because there's no command to break, right? This is what will happen. If A equals 1, you would first do B plus plus, followed by the next line of code, which is another B plus plus, followed by the next command, which is break. Breaks means the stop, right? So over here, let me kind of summarize it. If A equals 1, you would do B plus plus, followed by B plus plus, followed by break. If A equals 2, this is what you would do. You would do B plus plus, followed by a break. Basically, if you want to let it stop, you need to type in break. And then else, you do B plus plus. The default is optional. You don't have to put it in. If you don't put it in, it means that else do nothing. Okay. Any questions about the control structure? We are actually approaching the end of this lecture. There's a few more things like a loop and a print, and before we go into the in-class exercise. What if we don't have a break? That's a great question. Basically, if we don't have the break here, right? If you don't have the break right here, let me use a laser pointer just so that I don't roll right. So this break, the break, if you take it out, what happened is if A is 1, it will do B plus plus, B plus plus, B plus plus. Done. So there'll be 3 B plus plus. If A is 2, there'll be B plus plus, B plus plus, done. Otherwise, B++, done. Return, yeah. After this is basically the return. Basically, the end bracket means that this is the end of the switch statement. Okay, so to perform a loop, right, which means that I'm gonna repeat, do something a lot of times, n times here. You can use the loop this way. For I equals 0, this is the initial condition. This is condition check. This is what to do at the end of each iteration. So you can, depending on the version of C, if you use C++, in I equals 0 is okay. C code is not okay. You need to do in I somewhere first, and then you come in here and then say, okay, I equals 0. There's a little bit of a constraint here, but it's not okay. The compiler, when you compile the code, they will yell at you, but it's not a big deal. Basically, you know that okay, I can't do in I equals 0. I have to do in I followed by I equals 0. Is it important? Not really. These days, like compiler is advanced enough to know what you're trying to do. So if you, for the purpose of this class, which is we need to make sure you know C, just be aware that you cannot do in I equals 0. That's all. You can do a while statement, right? Which is wow. For example, while I is less than n, do something. This is one sample, right? Make sure that you increment, make sure that this loop doesn't go into an infinite loop with the while statement. Basically, make sure that at some point the condition check will become false so that you exit the loop. Do while is the same as while statement, but you would do the first iteration before you check the condition. You can use the command break to break out of the loop. Okay, so break is useful in the sense that, okay, if this happen, get out of the loop. It doesn't have to match the end condition, just get out right now. You can use continue. The difference between break and continue is this. Break would get you out of the loop. Continue would skip the iteration and go to the next iteration. And that's the difference. You can process text from the input and you can print something to the output by using printf and scanf. Basically, to print something to your monitor, we call it standard output. It's as the same name suggests. It's the output that is standard for you, like it is well understood. You use printf. For example, printf hello world. %d is a special character. %d means that I'm gonna represent a decimal number. D stands for decimal. If you do %s, is for a string. %c is a character. X is a hexadecimal number. It would look at the next input of my printf function. For example, here it would print hello world 10. If I do something like printf %d, %d, 2 and 3, what will get print here? What is the first %d? Yeah, basically you would print the first %d correspond to the first input here, would go here, and 3 would go here. basically now would get 2 and 3. That's it. It's as simple as that. And then to read from standard input, you can use scanf. For example, here, one thing missing actually, you would need to do. If you type in scanf %d colon a, it would complain. Basically, this read the number from the input and store it in a variable a. So this is wrong. You need to write in scanf up. Oh my god, I cannot. You need to put the ampersand in. Why is that the case? Okay, I'll answer that question in a bit. See how about see out. Why is this the case? We will talk about it when we deal with memory. The ampersand means certain thing, but right now just memorize it for now. In the next lecture, I think we'll talk about this in detail. The ampersand means that I want to write into the variable called a. Okay. C out is for, yes, exactly, it's for C++. It is a standard output. It is similar to printf command. So if you write in C++, you see C out a lot. I also use it. So basically think of it as it's a printf command. You can use printf in C++. You can use C out in C++. It's the exact same thing. All right. The last step that I want you to know is how to compile and run your code. It can. Basically, in C++, you can use printf. That's okay. I actually use that a lot because I start my programming days in C. So I'm so used to printf. So when people use C out, I'm still not used to it, to be honest. I still use printf a lot. So that's okay. It's the same thing. There's like a subtle differences between how they forward to the output, but it's not a big deal unless you like really care about syntax. How to compile and run your code. If you remember our first in class exercise, when I said do GCC dash version, this is what it's for. GCC is used to compile your C code into a machine language, right? This is the command you want to put it. Let's say this is your C code. You put in the command GCC, the file name. Exactly, it's the same as Java C, but let me kind of explain it for all your friends. Basically, GCC file name -o means that I want to create an output. This is the file name, what it's called. This is your binary file. Name. Right. Basically, then you can do ./output executable. This would run test.c. This is how you run it. All right. That's it for today's class. If you have any questions, what do we, how, okay. You mean should you save it as a .c file? Yeah, usually just save, when you write a program, save it as a .c file. It allow people to help identify that it's a C program. Then the executable, you don't have to have a file name at the end because it will become the binary code. Linux would know that, okay, that's a program you're supposed to run with it. It's not a text file. It's not a C program that you can understand. It's the binary code understood by the machine. All right. Before we leave today, in class exercise 4, finish it. By next Monday, I will be around to answer your questions. I just need to kind of save everything here and then switch to my desktop so that I can expand on the additional keyboard and mouse that I have, it's a lot easier for me to answer your questions that way. So give me like 2 or 3 minutes. I just need to kind of switch the setup. Uh, in the meantime, as I said, feel free to ask questions. And here are the reference. There's a lot of manuals about how to do formatting, how to run different program. These are posted on Canvas on this for this particular slides. The link are clickable, so you can click through the link. And at the end of the day, you can either also ask me or ask Google. Stack Exchange is generally useful. What do you mean by can you hard code it?
So just so we don't need a format. I just hard code the line and then Java and then
Okay, can you do it more like a human way and like finish the exercise the way we I think you understand what I want you to do. So can you
อัน
please
นี้ถามขำๆมาเนี่ยถามขำ
okay, yeah. So that's why so the word hard code means multiple things. That's why I want to ask like what you mean by that. It can be something interesting too, but which is more like how to optimize your code. Uh Okay, so that's the end of today's lecture. I would, as I said, I'll be around. I would just need to kind of change the setup back to my desktop. I would make sure I turn on the speaker so that I can hear what you say, but give me 2 minutes. Broader in-class assignment to be for the Google. Either through Google or ask me. Anywhere works. I think because I cannot cover every single thing in one lecture and all these like small syntax. Uh, uh, right now, asking me is a good resources. Aside from that, asking me through email is also another good resources. And then if you still have question, you can either wait until Friday. If there's an interest in basically have extra maybe half an hour Q&A session similar to like last week, I can do that as well. I can just pick a random time that I am available and I would just have a Q&A session that you can join and ask. Do we need to separate the problem into different file or just write all in one file? Either way works. No preference. I'm always on the side of like whatever works for you, right? As long as I can tell that you are working on the code and you understand what it's doing. Be aware that once you actually hit the job market and say the boss tell you to do this thing, be aware of like ask them, okay, what's the output format? What do people expect? That just to make sure that you don't piss off people who pay you. But for me, because I'm most of the time I just want to make sure you learn. I want you to focus on the learning phase rather than the formatting, the like the little detail that I know that you will be able to do. All right, so let